In this video, we're going to find the centroid of a region that's bounded by the curve y equals x squared plus x from 0 to 2. Now, here's our formulas for mass and our moments on the y and the x and how to find x bar and y bar. Now, what you'll notice, though, is because it's bounded by the y-axis, I can think of f of x as this function and g of x just being 0. So you can see that that's going to kind of simplify all my formulas. So imagine all these with g of x being 0. We're also going to do them with a constant density. All right, so let's see how that's going to simplify things. So what I think is the easiest to do is always find mass first. So the mass of this plate is going to be the integral from 0 to 2, because we're going in terms of x, and we're just looking at integrating the area of this curve times our density. So rho times x squared plus x dx. And we've got a relatively simple integral. Rho is just a constant, and then we can do this piece by piece. X cubed over 3 plus x squared over 2 from 0 to 2. And we don't even have to worry about plugging 0 in. So we're going to have rho times 8/3 plus 2 squared is 4 over 2. Now let's go ahead and let's finish this off. We're going to have rho. We have 8/3. This here is just 2, which is 6/3. So times 14/3. So 14/3 rho is our total mass. What's nice about that, that's the total mass for both of these. Now, when we go to find x bar, we're going to need m sub y. So let's give ourselves a little bit more room. So m sub y, notice it's almost the exact same integrand as it was for m, except there's an extra x in there. So 0 to 2, rho x times x squared plus x dx. So I'm going to pull out the rho, and I've got the integral from 0 to 2 of x cubed plus x squared dx. So that'll be rho times x to the 4th over 4 plus x cubed over 3 from 0 to 2. Plugging that in, again, 0 is just going to lead to us having 0. It's going to be rho times 16/4, which is 4, plus 8/3. So this is 12/3. So this is rho times 20/3. Since we're doing integrals, let's go ahead and find m sub x, and then we'll put them together for x bar and y bar. Limits are going to be the same, 0 to 2. One thing that you don't want to forget is that it's 1/2 of rho, or rho over 2. So there's an extra half in there. And now f of x gets squared. There's another video that shows where these formulas come from if you want to take a look at that. So I'm going to pull the rho over 2 out. 0 to 2, let's square this. That's x to the 4th plus 2x cubed plus x squared dx. Some of this I know I'm going quickly through. I'll leave it for you to check out some of the math going on here. So rho over 2 times x to the 5th over 5 plus, we're going to have 2x to the 4th, 2 times x to the 4th over 4. Simplify that in a second. And plus x cubed over 3 from 0 to 2. So again, we're going to have a fraction. So we have rho over 2 times 32/5. Let's make that just over 2 to hurry things up a little bit. 2 to the 4th is 16, over 2 is 8. So plus 8, and again plus 8/3. Let's give that a common denominator. Rho over 2 times, it looks like 15ths is going to be our common denominator. 96 over 15 plus 120 over 15 plus 40 over 15. So we got 160, 256. We have rho over 2 times 256 over 15. We can do a little bit of canceling, and that's going to become 128. That's probably about as simplified as we're going to get. Okay, I'm going to move up a bit here because I've got all my values here. And we'll double check and make sure that we like what we get for x bar and y bar. So first off, x bar is m sub y over m. So our m sub y, rho 20 over 3 over rho 14 over 3. The rows cancel, and we're going to flip and multiply, so we have 20 thirds times 3 14ths. The 3's cancel. We can reduce this by 2, and we get 10 sevenths for our x bar. So we get about 1 3/7. If we look, we have more of the plate over here, so it makes sense that if we put in 1, it makes sense that our x bar is going to be larger than 1 and smaller than 2. So we like that. That number makes sense to us. Similarly, y bar. Now m is going to be the same, so all we need is m sub x. And so this meets at 2. Now if x is 2, we're going to have 4 or 6. So this here is the point 2, 6. So our answer better not be larger than 6 over m. So we have rho times 128 over 15 over rho 14 over 3. Once again, the rows cancel because we had a constant density. And we end up with 128 over 15 times 3 over 14. It's going to be 1 and a 5. And we can cancel these a little bit. This is going to go to 7. This could go down to 64. And we get 64 over 35. So we get a number that's a little larger than 1, but a little bit smaller than 2. If we go back again, this is a rough sketch, but it makes sense that our center of mass is going to be down in this corner. So larger than 1 for both x and y, but smaller than 2 for both. So these answers seem pretty reasonable for our x bar and our y bar.